Hello viewers, welcome to this video on multiplication and division of fractions. Recall that in our previous videos we have done addition and subtraction of fractions with like and unlike denominators. Please, if you've not watched those videos before, kindly go to my page. The videos are there in my page. You will watch them. You need that knowledge as we progress, especially for the kids. Please do ensure that your kids watch all the videos. For today's video, we are going to just focus on multiplication of fractions. Probably the division of fractions, will take that in the next video. So multiplication of fractions is a very interesting topic. Let's see how it goes. Now, multiplication of fractions is probably easier than addition and subtraction of fractions. It's about the easiest part of fractions. As you can see on the screen, there's just a very simple rule for multiplying 2 or 3 or 4 different fractions. If you are given, say for example, a over b is a fraction, c over d is another fraction, where a and c, they are the numerators, and b and d are the denominators. Now we are multiplying these two fractions, as you can see, multiplication sign. Now the simple way to carry out this mathematical operation is you multiply a and c to form the new numerator, and then you multiply b and d to form the new denominator. So a dot c actually is saying a times c. Remember, I told you in one of my previous videos that sometimes we use dots to indicate multiplication. So a dot c means a times c. You multiply the numerators of the two different fractions. So a times c and b times d. So we have an example on the screen for us to drive home this lesson. First example we have there is the fraction 2 over 3 times 1 over 4. I told you it's very easy. So according to the rule, we'll have to just multiply the numerators 2 and 1, and also multiply the denominators 3 and 4. And it goes this way: 2 times 1 is 2, all over 3 times 4 is 12. Now we can reduce this fraction, this new fraction, which is 2 over 12. Remember, if the fraction is reducible, you go ahead and reduce it. How do we reduce it? Looking at these two numbers, we see that 2, we can use 2 to divide it, and 2 can also divide 12. Whatever you do to the top, you also do to the bottom. 2 divided by 2 is 1, and 12 divided by 2 is 6. And that's the answer. Very simple. Multiply the numerators together and multiply the denominators together. Let's do another example. First fraction is 3 over 7, and the second fraction is 2 over 5. We are asked to multiply these two fractions. It is the same rule. You multiply the numerators, and then you also multiply the denominators. So when we multiply these two numerators, 3 times 2 will give us 6, all over 7 times 5 will give us 35. We look at these two numbers, 6 over 35. There's really nothing we can do again. So that is the answer. It's easy, not so? Yes, very easy. So we look at still another example. 3 over 4 times 12 over 6. We'll have to multiply numerators. 3 times 12 to get the new numerator, and we'll also multiply the denominators 4 times 6 to get the new denominator. And 3 times 12 as we all know, that is 36, and 4 times 6, as we all know, that is 24. Look at this new fraction. There is something we can do to this new fraction. We can divide the top and the bottom by 12. I told you, whatever you do to the top, you also do to the bottom. And when you divide the numerator by 12, you get 36 divided by 12, you will get 3. And 24 divided by 12 will give you 2. So that is the answer. But let me introduce you to a very simple trick here in carrying out multiplication of fractions. You can see that as the numbers in the numerator and denominator gets larger and larger, we'll be finding it a little bit difficult to carry out the multiplications. So we're going to do something a little bit different. Watch out. So the fraction is 3 over 4 times 12 over 6. Now look at this. Something else we could do is this. Here I have 3 and here I have 6. I could see how I can reduce these two fractions. 12 is the same thing as 4 times 3. And 6 is the same thing as 3 times 2. Did you get that? So why did I do that? I did that because I know that 3 here can cancel 3 and 4 here can cancel 4. So what is remaining at the numerator is 3, and what is remaining in the denominator is 2. And that's the same answer that we got before, 3 over 2. So this method is going to become handy as the numbers that you have in the fractions are getting larger and larger. Let's watch out for more examples. Next example we want to look at here is this fraction, 6 over 12 times 18 over 12. Let's apply the method that we use, the second method that we used for the last example. I can write it as 6 12 is the same thing as 6 times 2. You agree with me? Yes. Here is 18, which is 6 times 3. You agree with me? Yes. And here is 24, which is 6 times 4. So this 6 will go with this 6. This 6 will also go with this 6. What we have left in the numerator is 3 all over the denominator. 2 times 4 is 8. Can we reduce this further? The answer is no. So this is our answer, 3 over 8. It's pretty simple, isn't it? And our next question, you can see that in this fraction the numbers are getting larger and larger. Yes, so this method becomes very handy. But we are following the same rule. We are multiplying the numerators, 24 times 45, and multiplying the denominators, 27 times 32. Watch out. So because the numbers here are becoming large, let's also break them down this way. The reason we want to break them down is if we decide to multiply 24 times 45, we'll get a very large number. For example, 24 times 45 is 1080, while 27 times 32 is 864. Those big numbers, one can easily get confused when you are in an exam situation or where you need to work very fast. That is why we apply the method of breaking down the numbers as we have seen earlier. So you can see that 24 can be expressed as 8 times 3. Do you agree with me? Yes, it's the same thing. 24 is 8 times 3, while 27 is 9 times 3. Now we are multiplying this by 45 is 9 times 5, while 32 is 8 times 4. So having broken down the numbers like this, you can see how they can easily cancel out. 8 here will cancel out this 8. 9 here will cancel out this 9. 3 will cancel out 3. And what's remaining will just be 5 all over 4. And that's our answer. We are leaving the answers as improper fraction. We are leaving this answer rather as improper fraction. In another video, we'll talk about how to work further on improper fractions, converting them to mixed numbers. However, for this example, let's leave it as improper fraction. So, because we were able to break the different numbers down, we're able to simply work it out without cracking our brain about multiplying large numbers. So take note of this example. Now, just to extend the rule a little bit further, if you have 3 fractions instead of 2 fractions, it's the same thing. As long as you are multiplying all the fractions, all you need to do is to multiply all the numerators together, a, c, e. That is, multiply a and c and e, divided by multiply all the denominators, b times d times d, and you get your answer. For example, here we have 45 over 28 times 22 over 55 times 21 over 9. Let's see how we break it down. You will agree with me that 45 can be expressed as 9 times 5, isn't it? 9 times 5 gives you 45. 28 can be expressed as 7 times 4. But watch what I'm going to do. 7 times 4 is the same thing as 7 times 2 times 2. Yes. So now we go to the middle fraction. 22 can be expressed as 11 times 2. And 55 can be expressed as 11 times 5. You agree? Now, the last fraction, 21 over 9, can be expressed as 7 times 3 all over 9. So let's make it clearer. 9 times 5 all over 7 times 2 times 2 times 11 times 2 all over 11 times 5 times 7 times 3 all over 9. Now that we have done this, you can see clearly that 9 can cancel 9, 11 can cancel 11, 7 can cancel 7, and 2 can cancel one of these 2 here. So what's remaining in the numerator? We have 5 times 3, which equals 15, all over the denominator. 2 times 5, which is 10. Yeah, we could have cancelled this 5 and 5, but anyway, it's all the same. 15 all over 10, we can divide this by 5 and also divide this by 5. So when 5 divides 15, you get 3. And here you get 2. And that's our answer. If we had watched carefully, we would have seen that this 5 could have cancelled this 5. So what will remain and the numerator will just be 3, and what will remain in the denominator will just be 2. But we didn't take note earlier, but it's all fine. So we have simplified the fraction and we have gotten our answer to be 3/2. So it doesn't matter if there are 2 fractions, 3 fractions, 10 fractions, as long as the sign in between them is multiplication. Just go ahead to multiply all the numerators to get the new numerator. Go ahead to multiply all the denominators to get the new denominator.